Hi there. All right, today we're going to be talking about linear regression. So go ahead at the top of your paper, write linear regression. Linear regression, also known as the line of best fit, maybe you've heard that term before, is something that when given a set of data is kind of a predictor or a summarizer or approximator of what the data is doing. So for example, linear regression is used a lot in the stock market because anytime you hear something about a prediction in the future, they're using their data points that they already have from different quarters or something like that. They're using those data points, they're plotting them, and then through the act of using linear regression, they are able to make predictions about their future or make generalizations about the data that they have. So, regression, go ahead and write this down. Regression equations approximate scatter plots. So scatter plots are a way to plot two variables on the coordinate plane. So a scatter plot has an x and y, and it has different data values, as you can see down here with our day and length. Our day can be our x and our length can be our y. And we're able to plot these points on the coordinate plane. And through the use of linear regression, we're able to say something about those data points, not just the fact that on day 1 it had a length of 20 and on day 9 it had a length of 24. We're able to talk about general trends of the overall data. So we're just going to go ahead and grab your calculators and we're going to go and do this together. So go ahead and do a new document. And today what we're dealing with is data and statistics. So click that. Oh, wait, no. We're going to start over. New document. First, we need to make it a list in a spreadsheet. So we can go off of our steps that we have on our worksheet. We're going to put our two variables in. So as I stated earlier, we're going to make our days in example 1 our x values, or in this case a in the beginning. So we're just going to label this so we can refer back to it later. So we're just going to say that it's days. Our b is going to be our other variable that we have, which is going to be length. So from here, we're just going to input our data. So we're going to put all the days that we have. We start at 1, our next data point is 3, then we go to 5, 8, and I'm just reading right across this chart and just plugging it in the calculator. So our last data point for days was 17. So we can see that we have a total of 9 data points. And as of now, we can't say anything general about what's happening with these data points. So now we want to put in our lengths. So I'm just going to go once again right across. So you can see we have day 1, the length was 20. So these should line up accordingly. And then if you look at this, you can see that it's increasing by 1 every time. So 21, 22, 23, 24, 25, 26, 27, and finally 28. So our last data point down here, day 17, has a length of 28, which does line up with our chart that we have on our paper. So from here, we want to be able to see what a graph is going to look like. So we can see this on the XY plane and be able to make generalizations about it and hopefully predict future points possibly. So what we want to do is we want to go back to home, and since we're talking about data and statistics, we're going to want to click this, it's a histogram, it's just going to be about data. So here's our 9 points that we have, but we also want to have it in terms of something. So we want our x to be in terms of what we said our x variable was going to be, and we had designated that as days. So the days are from 0 to 18 that we have here. But we also want our y to be designated as something. So we're not going to do days versus days. We're going to do days versus length. Ta-da! So here we have the data that was in that chart. We plotted it on the XY plane, and we can see that it's kind of going up. It has a positive slope, and it almost looks like a line. But we want to find the line of best fit, or this linear regression of these data points, to be able to make claims about it later on. So from here, we want to click Menu, and we want to analyze this graph. And today we're talking about regression, so number 6. And as you can see, there's a lot of different versions of what regression is, but today we're just going to focus on linear, so number 1, the mx plus b, which is the formula you're familiar with. And the calculator did some math, and it was able to determine that the linear regression of these data points is y equals 0.46x plus 19.54. So you're able to make claims about it later on. So now we're going to go back to our paper, and we're going to record what our linear regression was that you saw on your calculator. So it still should be listed with your graph. So we're going to round to the thousandths. So it's going to turn out to be y equals 0.460x plus 19.549. So in the future, if you just had these data points and then you created your linear regression that you have here, you can make claims about a day 18, a day 19 if you want, to be able to predict the future and see what the potential length is going to be of whatever this is. Okay, so now we're going to look down at example 2. And what is the equation of the line of best fit for this scatter plot? So basically the line of best fit, or linear regression, if you're doing it by hand, your goal is to include as many points as you can on that line and also split your data evenly. So just looking at this graph, I'm going to make these points a little darker. So we have our 9 data points here. Our goal is to create a line that has as many points as possible and splits the data evenly. So our first step is to sketch that line of best fit. So just looking at it, I can see that it has a negative slope going on here. As the x's get bigger, the y's are getting smaller, so it's going to have a negative slope. And I happen to see these 4 lines right here that make a line, and I don't think there's any other way to get more than 4 points on a line. So I'm going to sketch my line of best fit that I see here. And these lines do continue on. Okay. Now I want to determine my y-intercept of this line, and I can see that this is a good line of best fit because first off, it includes 4 points from our data, and it splits our data generally pretty evenly. And what I mean by splitting the data is that there's data points under this line and over this line. So I see 3 data points under my line of best fit and 2 points above, so let's split it fairly evenly. So I already know that it has a negative slope, and I already know, well, I'm trying to find the y-intercept, so where it crosses that y-axis. And I see the point right here is where it's crossing. So at 8, it crosses the y-axis. So negative slope, and then a y-intercept of positive 8. So let's look at our option choices and see if we can label this line of best fit. A is y equals x plus 8, so it does have that y-intercept of 8, but it has a positive slope, so that's not what we're looking for. Y equals negative x plus 8. It also has that y-intercept at 8, and it has a negative slope. Let's make sure our slope makes sense. So I can start at one point and go down and to the right. Yep, that has a slope of negative 1 over 1. So it's looking like our answer, but let's double check and make sure C and D don't work. Y equals positive 8x. That has a positive slope, so that'd be going this way, so that doesn't work. And then finally, y equals negative 8x. This also doesn't work because negative 8x would have a y-intercept at 0, so that doesn't work, and it would be a drastic downward slope, and we just have a slope of 1 here. So that is your lesson on linear regression, and the main thing to remember, this is actually a pretty important idea because you really can predict the future you have here. Using that line that you have, you can predict future data points or data points in between, so you could try to figure out what day 14 possibly looked like if you didn't get that data for that day. So So it kind of gives you just the general trend of what a scatter plot looks like. Alrighty, thank you.